Example 5 is just a slick example because it's really 4 examples in one, and don't have a lot of space to do it, so I'm going to use this right upper corner. If I need more space, I'll go to the next page, but I think I can get a couple of them in that way. So remember our different theorems. This looks like 2 secants, and remember what the 2 secants is that the external times the whole thing equals the external times the whole thing. And it's easy to get trapped up, and so just do what I just did. External times whole thing equals external times whole thing, and you'll be less chance of making a mistake. So the whole thing is 15, and the whole thing here is x plus 5. So we get external times 15 equals 5 times x plus 5. So we distribute, we get 90, 5x plus 25. We subtract 25 from both sides. We get 65. Then we divide by 5. We get x equals 13, and we're pretty happy because this is 13. I'm just going to clean it up, and then we'll go on to the next one. Okay, so example 2 looks like chords within a circle. So remember that one is each piece of the chord multiplies to give you each piece of the other chord. So when I do that, I'm going to get x times 3 equals 4 times 6. So I get 3x equals 24, divide by 3, x equals 8. So this is 8 here. And again, I'm pretty happy with that. It's pretty simple. So let me clean it up, and the next example is a little trickier. Example 3, be careful, it's a segment of secants, and so we're going to use that, and it's the same thing. External times whole thing equals external times whole thing. So let's do the whole things first. So I've got 3 plus x plus 2 here, which is x plus 5, and here I have x plus 1 plus x minus 1, and it turns out the plus 1 and negative 1 cancel out, and so I get 2x. Okay, so let's go with it. So external 3 times the whole thing right there, which is x plus 5, equals external, which is x plus 1, times the whole thing, which is 2x. Okay, so we're going to distribute 3x plus 15 equals distribute 2x squared plus 2x. I'm going to isolate, I'm going to get everything to one side and set it to 0. So I'm going to get 15 equals 2x squared minus x. Then I'm going to subtract 15. I'm going to get 0 equals 2x squared minus x minus 15. Well, I'm going to need some space to do the factoring on this. So I'm going to go to the next page, and I'll come back with the answers. So I already have it written there. And remember, the AC method, or by grouping, says you multiply those, and I'll get, when I do that, I get 30. and then I want to list my factors of 30. 1 times 30, 2 times 15, 3 times 10, 4 doesn't, 5, and 6, and that's all the factor pairs. And remember, each pair, because this is really 2 times negative 15, I want to subtract them. And what do I want to get? Well, I want to get what the middle term is, which is really negative 1. So I want to get negative 1 when I do that. And that would mean this pair here, because 6 minus 5 is 1, or 5 minus 6 is negative 1. So I really want 5x's minus 6x's, because that's negative 1x's. So I'm going to write everything that was in front. I'm going to group the first two terms and then find the greatest common factor for each set of parentheses. So that would be 1x. And this would be a negative something. Well, it looks like a 3 goes into both of those, and I'll get 2x plus 5. Remember, negative 6 divided by negative 3 is positive 2. Negative 15 divided by negative 3 is positive 5. And so this is nice because those are the same. So I can factor them out and write it once. 2x plus 5 times what's left in front are my other ones, which is really just x minus 3. And so I just know I know this or this has to equal 0. And this one is easy, x equals 3. But x could be something else, so I'm going to subtract 5. I get 2x equals negative 5, so x equals negative 5 over 2, or it's a negative 2.5. So I'm going to write those on the front page now. So let's try them in the formulas here. If you put 3, I'm going to try 3. 3 plus 1 is 4. 3 minus 1 is 2. So far, so good. And 3 plus 2 is 5. So definitely 3 works. The negative 2.5 may be trickier. So if we check it, negative 2.5 plus 1, that's negative 1.5. And it makes no sense for this to be negative. It's a length. So we right away know it failed on that particular check, so I'm not going to use negative 2.5. And I've got my answer there. So I'm going to use, in this case, x equals 3. Okay, the last one, number 4 on this example, looks like a secant chord, and it looks like a tangent chord there. And we know that the rule is the tangent is squared, and then it's still external times whole thing. So we'll write that in. 1 times, well, what's the whole thing? 3 plus 1 is 4. So x squared equals 4. X equals plus or minus 2 if I take the square root. Now I don't really want a negative distance, so I'm going to x equals 2. If I put 2 here, it makes perfect sense. Negative 2 length does not.